Hello world, this is Craig. Thanks for sticking with me through parts 1 and 2. This is part 3 where we're actually going to look at the documentation on the port configuration for the Cortex processor. So to see exactly how we're doing this, we need to look at the RM0090 reference manual for the STM32 405 chip, which is what we're using. And in this manual, we want to find the GPIO section. And in the GPIO, what we're specifically interested in is how we output. And so we can see the output configuration. So let's go to that page. And we'll see a diagram of the output configuration. So let's look at how this actually works. We see that here on the left-hand side is the processor. On the right-hand side is the real world. Here it says I/O pin. So this is what we're actually connected to, is this part out here that says I/O pin. This is where we're connected. But if we look on the left-hand side, we can see that we have here our output data register. So that's our ODR. We have our bit set reset register, our BSRR, and our input data register, our IDR. So the thing to notice is that this is our output pin, and when we're outputting, we have our output control. It has our two FETs, one pulling up, one pulling down. And in this case, we want this to only be a pull down. So we have this, we'll want this configured as open drain. So in other words, we allow it to float high, but then we'll pull it down when we want to set this to low. But a key thing is to notice that the input is always connected. This isn't like some of the processors that will disconnect the input while we have the port configured as an output. In this case, the input is truly measuring what signal is at the I/O pin. So when we have this configured as open drain, and if someone is pulling this I/O pin low, even though this port is configured as an output, we'll still be able to read it. We'll also want this VDD pull-up resistor turned on, and this is going to provide our pull-up for the entire bus. So let's look at some of the details in the output configuration and look to see what's important. It says the output buffer is enabled, of course, but the Schmitt trigger input is activated. So even during the output configuration, the Schmitt trigger input is activated, and the data present on the I/O pins are sampled into the input data register every clock cycle. Okay, and this is key. So we don't have to toggle this port between an input port and output just to read and write this bus. We can configure it as an output port and then just read it whenever we want to sample the bus. And so how do we actually configure these ports? Well, if we continue in this reference manual, we find the GPIO registers. The first thing we need to configure is the mode, the GPIO, the port letter, and then the mode register. And in our case, we're going to want this to be a general purpose output. So we will want our mode to be a 0-1. The next thing we set up in the next register is the output type register. And in our case, we're going to want this to be open drain. So we will set up that bit for our port, which happens to be pin 11 on port I. So we will set this to be a 1. Next thing we have to configure is the speed. In our case, we probably don't need it, but we're going to set this to be high speed. So we'll set these two bits to be 1-1. And finally, for the pull up, pull down register, we want this to be a pull up to provide the power to the bus. Okay, that's the end of part 3. As you can see, what we're going to do next in part 4 is start looking at the actual code to do this. So I hope this was useful. Thank you.